Hey, if you're watching, I am just getting this all set up and we'll be going through the live very, very shortly. So I can see YouTube is all sorted. Let me just check if Instagram can see okay. Yeah, I think I might need to just edge over a little bit. And right, I'm just going to get TikTok set up and then we are good to go for our first weekly live of the new academic year. So let me just set it up on TikTok. Go live. This here. My hand will be out of your way very soon. I'm just doing that. Cool. I think that's all sorted. Okay, so welcome to the first live of this new academic year. We are going to be going through Year 12 content because you are either here as a Year 12 or as a Year 13, and either way that means you'll be able to access this content. So whether you are a new Year 12, this will likely be some of your first lessons, and if you are a Year 13, then this is great revision for you. So this is actually page 3. That's page 2. That's where I wanted to start from. So the very first part of Year 12 content is monomers and polymers. And that actually covers a lot of what you would have known at GCSE anyway. So it's knowing that a monomer means one, and it's small units from which larger units are made. But what you do need to know is these examples. So you need to know monosaccharides, amino acids, and nucleotides, and you learn those in the biological molecules topic. So that will be coming up in the biological molecules topic. And polymers, those are molecules made from larger ones, usually thousands of monomers bonded together. So we've just got a visual representation here. But the key thing is, know those two definitions, and here are your examples. Condensation and hydrolysis reactions, it falls into this bit of the spec, the monomers and polymers, and it doesn't matter which exam board you're taking. Although these are my AQA notes, all exam boards learn this content about monomers and polymers, condensation and hydrolysis reactions. So a condensation reaction, I always think of this as like a 3-part definition is what you need to consider. So you have a condensation reaction, it's the joining of two molecules. You get a chemical bond forming and water is eliminated. So those are your 3 key concepts. So if you're making flashcards as you go, you'd need to have condensation reaction, and those 3 things would be bullet pointed to make your flashcard for your definition of a condensation reaction. Hydrolysis reaction is the opposite. And if you remember, as hydro means water, and wherever you see lysis in biology, that means to split. So hydrolysis is splitting using water, but your definition is you're breaking a chemical bond, and that is going to split apart 2 molecules or between 2 molecules, and it uses water. So you could get exam questions where they ask you to define a condensation reaction, or it could be define a hydrolysis reaction, or you might have to apply it to a particular biological molecule. So for example, we've got nucleotides like RNA and DNA. There's our single monomer, and that can then form a polynucleotide, the polymer, due to a condensation reaction, and you can break it up or hydrolyze it through a hydrolysis reaction. Monosaccharides, that is the monomer of carbohydrates, for example glucose, and those will join together via condensation reactions to make polysaccharides such as starch, glycogen and cellulose. And they are hydrolyzed, broken down, by hydrolysis reactions back into the monomers. And then last, we've got our amino acids. Condensation reaction occurs between multiple amino acids to make a polypeptide, which makes your full protein. And then a polypeptide is hydrolyzed back into amino acids. So that's our monomers, polymers, and the condensation and hydrolysis reaction. So what I then like to do in these lives is we go over a little bit of theory, and then we have a look at some exam style questions as well. So For this one, I've got, this is actually from my active recall workbook. So this is, I often get questions on how can I use your notes, how can I use your resources? And this is one thing I think is quite useful. Use the notes to get an understanding to start with, and then you can test yourself using the active recall workbooks. It's just a series of short answer questions. So it's a kind of like a bridging gap between doing exam questions, because this is just checking your knowledge. So can you remember it? Okay, so then we've got as our first question, give the definition of a monomer. Now I can see we've got a few people watching live. These do get recorded and then they're uploaded afterwards. But whether you're watching on YouTube or Instagram, into the chat box, or in fact, I've got TikTok over here as well, into the chat box, what is your definition of a monomer? So what is a monomer? That was the very first thing we said. I'm going to start writing that in. Okay, so small units that can be bonded together to make larger units. Yeah, excellent. I can see YouTube, Jasmine, you've got the correct answer there. Brilliant. Let me just have a look. TikTok. Yeah, Jack's got a good answer there. Cool. Right, then we've got a definition of a polymer. So a polymer would be a molecule made of many monomers bonded together. So that's what I'd say for my definition of a polymer. Right, 3 examples of monomers. So the exact name. So I'm going to have a look in the chat box. Ziza, yeah, good definition of polymer there in YouTube. I'm going to have a look now at TikTok. See, can we name 3 monomers? Someone said glucose. Yep, excellent. Let me head over to Instagram as well and see if we've got any answers coming in on Instagram. I don't think it's actually really showing me the chat on Instagram. So if you are contributing, sorry, I can't actually quite see what you're saying. Right, I've got nucleotides, sugars, amino acids. Amino acids, yeah, awesome. So I'm going to say for this one, amino acids, nucleotides. But you could have said nucleotides, or for that same one, we could have had RNA or DNA, but because that doesn't really clarify whether you mean the RNA nucleotide or RNA polymer, if you were going to say those, we'd have to say RNA nucleotide or DNA nucleotide. So just to clarify that with those ones, when it would be acceptable. And then the last one is the monosaccharides. But you could have given examples. So you might have said glucose, fructose, galactose for that. Right, what is a condensation reaction? And we've got a hint. It's a 3-part definition. So 3-part definition for what is a condensation reaction. So just to make you aware, you can bullet point all your answers in the actual exam questions. So if you are looking at this for the first time in year 12, this obviously is note form because it's the active recall workbook, but these would have all got 4 marks if it was an exam question. And the way I'm going to bullet point this helps me to remember the definition, but also you'd get the marks in the exam. And I do like to bullet point it just to help me remember. So we get joining of 2 molecules. That's my first one. Forming a chemical bond. And you have to say chemical, not just bond. So forming a chemical bond. And then lastly is eliminating or removing water. So a molecule of water is removed for that to happen. Yeah, excellent. So Jasmine and Yasmin, I can see you've both got that answer there. Cool. Next, we have what's a hydrolysis reaction. So again, we've got our hint. It's a 3-part definition, so you can bullet point this in the exam or in this active recall workbook, or if you've got it flashcards, 3 bullet points. So hydrolysis, remember we said hydro, think water, lysis means to split. So this would be breaking apart a molecule by breaking a chemical bond, and this time it uses water. So that'd be my definition there for that one. I'm just going to have a little look at some questions. Does starch break down into maltose by hydrolysis? Yes, it does. That's a really good example of a hydrolysis reaction that you would have learned at A-level, but also GCSE in digestion. So all of digestion are examples of hydrolysis reactions. This is relevant for all exam boards. So although this says AQA, you learn this in all A-level exam boards, and it's like the key thing that you would learn as well. Right, let's then see. The next bit is then going on to monosaccharides. I'm just going to go back to the notes at this stage because we haven't gone through that theory yet. We've gone through monomers and polymers. Let's now have a look at the carbohydrates before we have a look at some of those questions. Okay, so carbohydrates will be the first biological molecule you'll learn, probably for all exam boards. And they're a key biological molecule. They can store energy or store glucose, provide structural strength, and they contain 3 elements: carbon, hydrogen, and oxygen. So just a bit of a brief overview to start. I've got my summary diagram here. I think something's gone wrong with the way I've printed it though, because I've got fructose popping up there when it, I think it was meant to be over there for a typo. But there we go, I've got fructose. But large carbohydrates such as starch are made from monosaccharides. And we're basically being told the monomer of carbohydrates is monosaccharides. So mono meaning one and saccharide means sugar. So where we can see these terms polysaccharide, disaccharide, monosaccharide. Mono means one, di means 2, poly means many. So where we've got monosaccharide, saccharide, which we can see written here, means sugar unit. So monosaccharide is 1 sugar unit, so we could think of that as just a single hexagon. Disaccharide means 2 sugar units. We've got 2 bonded together, and that'd be due to a condensation reaction. And then polysaccharide means many sugar units bonded together, and so on. And then we've got the examples that you need to know. So you need to know glucose, fructose, and galactose as examples of monosaccharides, maltose, sucrose, and lactose for disaccharides, and then starch, glycogen, and cellulose for the polysaccharides. And some of these are probably familiar to you already if you're in year 12 and you're only just starting. Year 13s, they should all be familiar to you. It's just good revision for you. Because you do learn about starch in GCSE. Starch is a store of glucose in plants. Glycogen is a store of glucose in animals. Cellulose is made of glucose and it's in the cell wall. It provides a structural strength. Okay. Sorry, I just went quiet for a minute because I could hear a baby crying, but it's outside and I hear the parent with them, so it's fine. Sorry. Temporary panic, but don't worry. Whoever's baby that is, they've got a parent with them and it's all good. Right, where was I? Monosaccharides. So monosaccharides are sugars. That means they're going to be soluble, they'd be sweet, but you don't really need to know that information. But what you do need to know about monosaccharides is glucose and the structure. Now this is where it is slightly different for different exam boards. All exam boards, you need to know glucose is C6H12O6. You need to know there are 2 isomers, which means you have the same molecular formula, C6H12O6, but structurally the atoms are arranged differently. For AQA though, this is the level of detail you need to learn the diagrams in. For other exam boards, you need to know it in more detail. The way to know is have a look at your specification. It will have the diagram drawn for you so you know what level of detail you need to know. But for alpha glucose, I always think like this one is pretty much symmetrical. So you have the two hydrogen atoms on top, hydroxyl on the bottom, and then you have the oxygen there and the branch coming off. Other than that, it's symmetrical. Whereas beta glucose, it's opposites. So you have your hydroxyl on top rather than hydrogen. So that's the only difference is on carbon 1. For beta glucose, the hydroxyl's on top. For alpha glucose, on carbon 1, the hydrogen atom is on top. And that term I'm using, carbon 1, you don't actually have to be able to number the carbons, but you always go clockwise from the oxygen, and wherever you have a angle here, like a bend, that represents where there's a carbon. So that is our first carbon, so carbon 1. Here's another one, carbon 2, carbon 3, carbon 4, that'd be another one there, carbon 5, and off the top is carbon 6. So it's normally described as on carbon 1 for beta glucose, the hydroxyl group's on top, hydroxyl, that's what an OH group is, and the hydrogen atoms on the bottom, and it's the other way round for this. Okay, let's move over then to the active recall workbook and take a look. So we have got name 3 common monosaccharides. Into the chat box then, let's name 3 common monosaccharides. Alpha glucose, beta glucose, fructose, yeah. Lots of answers there on TikTok, brilliant. So I'm going to go for glucose, fructose, and galactose. Next then, let's see the next one. So our next one is name 2 isomers of glucose. So 2 isomers of glucose, we have alpha and beta. We could do alpha, beta as those 2 symbols. And then we have the next bit, which is naming, or we've got the name, but then you have to draw both of those isomers as well. So let me start drawing that. I'm going to start here with alpha. And I always draw the ring. And when I say ring, it's a hexagon. With my oxygen in, branch coming off the top. Same with the beta glucose. I'd always start at that because they both have hexagon with oxygen in the top right. Branch coming off the top. Then all you have to remember is the other parts. So we've got, for alpha, this is the one where it is symmetrical. So we have hydrogens on top, hydroxyl coming off the bottom. Beta, that is where it's flipped round on carbon 1. So hydroxyl on top and your hydrogen atom on the bottom. Okay, so that's our alpha glucose. Last thing we're going to have a look at then is the disaccharides. So that's the final thing we're going to have a look at today is disaccharides, which is go back to the notes. You can actually get 10 pages of these notes for free. I think it's actually this section. So if you did want to try them out, I've got them for OCR, Cambridge International, and AQA. If you comment on any of my Instagram posts, free sample. You get the link to download the free sample of my notes. I've got them for GCSE as well. But where has... I don't have my disaccharides printed. Okay, well, in which case, disaccharides, let's just jump straight into the questions. So describing how a disaccharide is formed. Disaccharides, remember we said that is di means 2, saccharide means sugar. So that is 2 sugar units. So a disaccharide, to join them together, making a chemical bond, this is taking us back to that definition here, condensation reaction, where we've got joining of 2 molecules, forming a chemical bond, eliminating water. So describe how a disaccharide is formed. I would say condensation reaction. Between 2 monosaccharides. And we haven't actually talked about the bond yet, but the bond that is formed is glycosidic bond. Okay, so that is how a disaccharide is formed. Last little bit here, I don't know if I'm going to be able to fit it in because it's so small, but we've got the word equation. So our 3 disaccharides are maltose, sucrose, and lactose. What they all have in common is it's a condensation reaction, which means water is removed. So all of them will be plus water as a product. They all contain 1 glucose. So that's the same for 1 reactant for all of them. And then the only thing that's different is you need to remember what the second monosaccharide is for each of these disaccharides. So glucose and glucose make maltose. Glucose and fructose make sucrose. And glucose and galactose, it's got lactose in the name, make lactose. So that covers the first 2 or 3 lessons of Year 12 biology, or Year 13's, it's a bit of revision. It is quite a big jump from GCSE. So if you are new to Year 12, it is a big jump from GCSE. There's loads of new reactions. It's quite chemistry heavy at the start. But the more you go over this content, the easier it will feel. Because at this stage to you, it probably feels incredibly difficult. If you ask any Year 13s that are watching, they will think that this is probably one of the easiest topics. But they wouldn't have done when they first learnt it. When they first learnt it, they would have felt the same as you, that it's, I'm so lost, there's so much information. But as you build on your skills and the more you look over this content, it does start to sink in. So the key things are making sure you can understand it. So that could be reading over your notes or using notes like I've got here, or my free YouTube videos. I teach all of it for free on YouTube. Then it's testing, can you remember the information? And that's where you could use my active recall workbook, or you can use your own flashcards or my flashcards, or you could just do things like blurting to test yourself. And then the final step is exam questions. And I do lots of that in the Biology Study Club, which is my monthly membership, where it's basically like group tuition multiple times a week. And we do lots of exam questions and teaching as well. Obviously, I've talked there about a mixture of things that you'd have to pay for. There's loads of things I have there for free as well if you're not in a position where you'd want to or able to pay for resources. I do this for free every single Thursday. You also get loads of free exam questions on my website, lots of free downloads as well. And I've got the entire A-level for free on my YouTube channel, Miss Estrick. Biology, Miss Estrick Biology, that's what it is on YouTube. But that is it for today. Hopefully you found this introduction helpful. These do all get recorded, so it will be saved to my YouTube channel and to my Instagram. And I will see you next Thursday, everyone. Bye.